research. I'm using the chat GP. No, I'm using the quadrant. Here in the quadrant is a quadrant, and we are trying to understanding what is the high performance vector search means, and we can start with the solutions, the use cases. So it is solving the use cases like a RAG, recommendation systems, advanced search. So now clicking on the use cases and understanding the, so this is the points I'm capturing, and we need to understand the advanced search. That's what the advanced search capability is. So there it is helping users to get the precise tailored content to users. So this can be used for the job search applications where if you type the, so, so if you type any job keyword, it can bring the relevant information. So here, so now you can see the demo over here. It's the demo where we type a quadrant, it will bring the quadrant related to the data. Same thing, with it's a neural or text is something different. Neural work is differently, but now we will understand all these features. Now there we are understanding semantic search. So that is helping us quadrant optimizing similarity search, identifying the closer to database items. So that's what I'm capturing here. Um, so then, right, so that is helping a semantic similarity multi-model hybrid to such a capabilities. Our target to going on these points and trying to create the right? So the similar applications, a quadrant to similarity search application, fast API. But this is helping in the e-commerce and healthcare. So either we can do something like this, or we can type quadrant to e-commerce recommendation systems in similarity search application. So there we need to understand the quadrant and how it is using in the e-commerce. So then how it is using in the recommendation systems, and these are the right. So then this is the technique actually. Okay, so that is what we are trying to understanding how e-commerce industry can benefit, and we can send the case studies much more deeper information over here. So there is a products where products vector, and we can search the information, and similar can bring the similar products. So then the catalog. So here we can use the chat GPT or the GitHub Copilot to complete this application. So we have the SKU. So then by ingesting this data, so using the data, and we can get the similar products. So similar products. So that's where we can see the difference between the Elasticsearch and Elasticsearch and as well as the quadrant search. There is something maybe a different. So that's what we are trying to understanding quadrant to enhance a search, offering semantic similarity multimodal. So this is what we want to understand for the different industries. So that's where we are writing these programs and so writing these programs and understanding the either in the cloud, right? That's the program we can understand. We need to execute or so similarly it is also saying similarity search and to and the let's say RAG actually. So or the image search model in the e-commerce to e-commerce RAG application fast API. So this one can give us the information how RAG can use in this. So previously we have seen the similarity search recommendation systems can use it. Now we are exploring the how RAG can be used in the e-commerce similarly in the different product like a different products like a healthcare, different ones. So those use cases we are studying here and digging deeper. Now we can say semantic search, quadrant optimizes similarity search, identifying the right, and it's also using the image retrieval also. So I captured over here. So hybrid search for text. So by combining dense vector embeddings with a sparse vector, BM 25 quadrant process semantic search to deliver a context-aware result. So this is another area we need to do the deep research on how the hybrid we are looking for software developers. So this is another way for the right, for the job search we can use by executing this program or understanding. So till now we got to information, so we can use for semantic search and as well as the hybrid to search when text. So that's what by combining dense vector embeddings with the sparse vectors. So that's what it is saying. So we need to understanding what is this mean. So this mean for the post semantic search to deliver context of the results, uh, transcending additional keyword search. So another thing is a multimodal search. So it is also saying the multimodal search, or we can make this as a separate items for the so we can use for the recommendation systems and to RAG to image retrievals. And afterwards we'll compare the same technique for the PG vector or wave or any domain specific ones. This right, so these things are helping. So multimodal search is a right indexing, retrieving various data formats. So we can put a text to video and audio. So that's what by putting the so how we can see the multimodal search can help in this area. So like this, we are exploring the different capabilities as part of this PhD level deep research. And also we'll go through this documentation and understanding, go through line by line vector databases or a relatively new way of interacting with abstract data representation derived from opaque machine learning models such as a deep learning architectures. So we need to study this line by line and understanding, then able to solve the problems like a semantic search, recommended systems, uh, and able to quadrant is a provides a production ready service, API, manage points, additional payload. You can think the payloads pieces and you can get a quadrant with the pipe. So this is the library we can use to get the data. Right, so this is a vector database and OLTP database is having a columns and row. That's what we are using our right OLTP to MySQL. Now OLT OLAP databases are columns and rows, but it's a different things, right? For the analytic purpose. So vector database having the dimensions and vectors. So ID, so okay, right. So these understanding these differences and understanding the what is the collection means. So I'm not going in every line, but you guys need to go through every line and understanding the cosine similarity, how cosines, and yeah, right. So now again, we can put a, right, in our experience information, we can put the, so we can understand. Okay, over here. So this is a rag for excellent icon stack application and see features, natural language transformations, and sample products and demonstrate how semantic search works better than keyword matching. For example, phone with a amazing camera will intelligently return the rank to relevance. Actually, that's what okay, right we are trying. So similarly, we'll use we'll use this application Qdrant again. I want to learn the cosine similarity. Let's say. Okay, so Qdrant. So quadrant similarity one. Then I can say maybe I can put a cosine similarity e-commerce domain. We can put a domain healthcare, education, job search, those domains, and we can ask those try to use the fast API. So you will get the full application actually. So like this, so we will our target to understanding the what is the cosine similarity, dot products, and Euclidean distance, how that is the right, how that is a difference between the okay, so yeah, that also. So we need to understand all these informations. Key thing is that understanding these ones and with these types, right, these domains, how it is helping in the legal tech, and so then how AI agents in the legal tech, and yeah, so those, so that combinations, so you can work on. So we can see how the legal tech is helping legal search, contract analysis, compliance workflows, vector database AI can solve missed anomalies, costly mistakes. Then we can go contact landmines everywhere, hidden discrepancies. Yeah, so this is a good one. Okay, right. We are thinking from many days on the legal solutions, and if we solve this problem, and we cannot the legal guy said. So Ritika will lead this. Okay, right, this exercise.